This is the beginning of space and time. The Big Bang, the moment when the known universe came into existence in a single cosmic symphony of explosions at high energies resonating 13.8 billion light years away. At roughly 10 to the negative 37 seconds into the expansion of the universe, a phase transition resulted in cosmic inflation in which the known universe grew exponentially. It was characterized by large density fluctuations due to the uncertainty principle of quantum mechanics. Einstein wrote down the field equations describing the inextricable link between the curvature of space-time and the movement of matter. If one were to extrapolate the Einstein field equations in the high-density region of space-time, there would be a singularity where the Big Bang model breaks down. They only describe the evolution of the universe after the Big Bang, but there's no insight into the Bang itself. What mechanism would fuel such an impressive cosmological masterpiece? The so-called cosmological constant, lambda, in the Einstein field equations drives this expansion. If space is filled with a certain uniform dark energy, the gravity generated is repulsive, causing each galaxy to push against one another, thereby driving the expansion at an ever-quickening rate. The most important facet of this theory is that dark energy is a consequence of a so-called effective quantum field theory of the universe, which guarantees that not all of this fuel was used in the early epoch. In particular, this means that the Big Bang was most likely not the only such cosmological outburst of space, but rather one in an array of Big Bangs generating a realm of universes, a multiverse. But there's a catch. Each universe must have extra compactified dimensions wrapped up in their very geometric structures. Edwin Hubble observed that distant galaxies were accelerating away from us, establishing once and for all that our universe is expanding. In the 1990s, astronomers shocked the world, revealing that the expansion is speeding up. If we analyze matter on incrementally smaller scales, first we see molecules, then atoms and subatomic particles, and finally up and down quarks. If we continue to examine more finely, according to string theory, we find infinitesimal vibrating strings of energy. The strings can vibrate in different configurations, giving rise to different species of particles, electrons, muons, neutrinos, photons, but such a theory is only effective with more degrees of freedom, that is, extra dimensions of space. String theory posits that on remarkably small scales, there are additional wrapped-up dimensions that four-dimensional beings, like ourselves, cannot perceive. The extra dimensions of space-time are conjectured to take the form of a so-called six-dimensional Calabi-Yau manifold, a rich, enumerative geometric structure dictating the behavior of strings. The geometry of the hidden dimensions restricts the modes of vibration. Each of these shapes are equally as likely to be real, giving rise to a multiverse with universes each of different physical features, with varying amounts of dark energy endowed by the extra dimensions of space.